It's so fabulous to be back with you for video 2 of 3 tonight. Yes, there are 3. This is the second one, and this one is super important, ladies and gentlemen. Multiplying and dividing both sides of an inequality to solve. This is case 2. So, first of all, we started off with adding and subtracting both sides of inequalities, and it didn't matter. When we added or subtracted, that inequality symbol remained true when we added or subtracted the same number to both sides. Then, in our last video tonight, the one just previous to this one, we multiplied and divided both sides of the inequality by a positive number, and well, nothing happened to that inequality. It stayed true. Well, case 2, as you already know because you've taken some notes, so you are aware, case 2 is a little bit different beast. Case 2 says that when you multiply or divide each side of an inequality by a negative number, that the direction of the inequality symbol must be reversed. If there's a negative, you must reverse the direction of the inequality for our inequality to be true. So let's take a look at that numerically. This is where you really see it, numerically. So we understand that 5 is greater than 3. If I multiply both sides of that inequality by a negative 2, well, I get negative 10 on this side, I get negative 6 on that side. And you and I both know that negative 10 is not greater than negative 6. If I just drop that inequality down and say greater, it's not true. So following what we just said, when we multiply by the negative, we have to reverse that inequality. We reverse that inequality for that statement to be true. Negative 10 is less than negative 6. And the same holds true when we divide. If I have 10 is less than or equal to 15, which in fact it is, and I divide both sides by a negative 5, I would have negative 2 and I would have negative 3. And again, that inequality cannot just be true. I have to reverse it to say negative 2 is greater than or equal to negative 3, because that is a true statement. So, of course, doing things algebraically with letters, we would say A is less than or equal to B, and if we multiply by a negative C, we would say that A times a negative C is greater than or equal to B times a negative C. That's what we would say. We would reverse that inequality symbol. You're going to see me draw that arrow showing the reversal of the inequality as we do this. And of course, A being greater than B, if I divide by a negative C, I would get A divided by a negative C is less than B divided by a negative C. I must reverse that inequality symbol for that statement to be true. So let's do a couple of those examples and move right through. Remember, ladies and gentlemen, you might want to watch, listen, and learn first, then pause to write, because I'm going to be talking fast, and in some of these, there's a lot of things to take into consideration. So it's just my recommendation that you watch, listen, learn, pause, write it all down, and then go on. Here we go. Number 5, x divided by a negative 3 is greater than negative 4. So the first thing I'm going to do is say, to isolate this variable, my inverse operation is to multiply by a negative 3. And I'm going to do that to both sides to isolate and keep my inequality true. So I left on this side with x. On the other side, I have 12. And of course, I have bells and whistles going off in my head. Ding, 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 ding. Woo, woo! I'm multiplying by a negative number. That means I've got to reverse the inequality for that inequality to be true. And I'm going to come over here and I'm going to put 12 as my target number. Now I'm going to do something a little bit different because I'm dividing. I'm going to choose my next two numbers, greater than and less than my target number, to be compatible with 3. So I'm going to put 15 is the number greater and 9 is the number less than. I'm going to come to my inequality statement, my solution. I'm going to say x is on the left, so I can put a open circle on my target, and I can draw my arrow going to the left to say that this is true. So now I'm going to conduct a test, and I'm going to see, did I do this correctly? And the first thing I would do is I'm going to pick 9 because 9 is in the direction of my solutions that say those are true. These are my solutions. And I'm going to substitute that in, and I'm going to say 9 divided by -3 is greater than -4. My original statement right here is written substituting that 9 in. And then when I say 9 divided by -3, well, that happens to be -3. Is -3 greater than -4? Well, yes, it is. That means that our solution of x being less than 12 is true. We did it correctly. Had we not done it correctly, we would have had the wrong answer, ladies and gentlemen. Moving right along. Oh, you might want to pause, write all that down, and then join me for the next example. Example 6. 5/10 is less than or equal to -y divided by 2. So, of course, I'm going to multiply both sides by my -2. And I get -1. Taking my inequality symbol, bells and whistles, ding, 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 woo-hoo, multiplying by a negative, I've got to reverse that inequality, make it greater than or equal to y, because these simplify out. And, of course, adding to our difficulty, we've got our variable on the right, and we don't like it there. So I'm going to rewrite it, putting it on the left and say y is less than or equal to -1. Okay? So now notice, I've got the inequality pointing to the variable, and it stayed pointing to the variable. And I know some of you are going to say, but Mr. Ross, hold on. Whoa, Mr. Ross, wait a second. This inequality symbol looks exactly like the inequality symbol in the beginning, and now it's not reversed anymore. Well, in fact, we did reverse it, because remember, right here, we reversed it when we did the solution. So we reversed it when we solved the inequality. We just rewrote the inequality in a different way to say the same thing. So this is a true statement. And I can then target my target number on the number line. I have 0 as being greater, -2 as being less. I'm going to come up here, put my target number as a closed circle because it's included in the solution set. My inequality points to the left, so I can graph to the left because now my variable is on the left because I rewrote it. Very good. Let's go to example number 7. You might want to stop, pause, and write this one down before you move on. Example 7, now we're going to use division. Case 2, division, which means we're going to divide by a negative number, and then we're going to graph our solution. So, taking -5b greater than or equal to 35, the inverse operation is divide by a -5. And of course, we're going to divide both sides by a -5. We're going to go ding, 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 woo-hoo, because we're dividing by that negative. So now b, reversing that inequality, has to be less than or equal to -7. I can come over here and put my target number, -7. My inequality statement, I like it because the variable's on the left. And I can take -6 is greater, -8 is less. I need to use a closed circle because our target number is included. The variable's on the left, the inequality points to the left, so I'm going to graph to the left. Outstanding. And of course, if you wanted to verify, you could certainly conduct a test. Ladies and gentlemen, pause the video, write it all down, and join me for example number 8. In example number 8, we have a -4 2/10 being less than a -7/10 y. Well, that's because that's what it says. That's why. No pun intended there. Anyway, to isolate my variable y, I'm going to multiply both sides by a -7/10. Right? Over here, -0.7. Ding, ding, ding. Woo-hoo! I'm multiplying by a negative. That inequality symbol must be reversed. Negative. Did you guys just see what I did? Did you just see what I did? Well, okay, I could either redo this whole entire video or we're just going to fix it right now. We're currently multiplying. I was wondering how many of you were screaming at the video. All right, we are currently multiplying by a -7/10. So the inverse to solve, to isolate, would be to divide by negative 7/10. Hello, we're dividing by a negative 0.7. Now we're going to get it correct. Thank you for yelling at me. And of course, the bells and whistles still went off. We have 6 is greater than y. Ding, ding, ding. We reversed the inequality symbol because we divided by a negative. Now, of course, I don't like my inequality written with the variable on the right. So I'm going to rewrite it with the variable on the left to say y is less than 6. Of course, one of the ways to understand rewriting that, I'm shocked I haven't said this to you before. If I put in 6 is greater, what number is 6 greater than? I'm just going to put 5. Well, if I come over here and put a 5 there, a 5 is less than 6. Isn't that the same as 6 is greater than 5? Yeah, that is true. So that's why we're rewriting it. Plus, we can graph it easier with it on the left. Plus, we just like saying it with it on the left. So I'm going to come over here and put my target number 6, number greater 7, number less is 5. I have an open circle on my target number because it's not included. Now that my variable is on the left, I can just follow the inequality symbol and graph to the left. Woo! Ladies and gentlemen, had to get through this one. Thank you for yelling at me with this example when I started doing it incorrectly. You guys really helped me there. All right, let's move on to our second quick write of the night. There's 2 of them. Please copy them both down. Then you're going to solve them. And of course, you're going to make a graph and graph them. Take a quick break. Come back. Our last video tonight is really short, but we do have to do it because I didn't want to make this one super duper long. Ladies and gentlemen, I'll see you in a few minutes.